Welcome everybody. Today's lesson is all about circles. We're going to discuss how to find the area of a circle, the circumference of a circle, arc length, and the area of a sector. So fasten your seatbelts, here we go. First things first, when talking about the area of a circle, we need to look at the formula. Pi times the radius squared. You'll remember from earlier in your math careers that pi is a ratio of the circumference to the diameter. When we're talking about exact answers, we're going to leave pi in our answer, and we'll talk about that as we go. Circumference can be written one of two ways. We can write it as pi times the diameter, or as 2 pi r. Reason being is we can either multiply pi times the diameter, or since the diameter is twice the radius, 2 pi r. Now, looking at the diagram down below, you can see that our circle can be split up into a few different sections. First of all, using the radius, the distance from the center to the edge, and the diameter, the distance from one side of the circle to the other, passing through the middle, we've created a couple things called arcs. Now let me highlight one of these arcs for us. The way to find the actual length of this arc would be to take the circumference and multiply it by the degree measure of the arc divided by 360. So essentially, we are trying to find what percent of the circle is shown by the given arc. Now again, this is the arc length. Now, if I filled in this area and wanted to find the actual area created by that arc, that would be called finding the area of a sector, and we find it in much the same way. The area of a sector is the degree of the arc over 360, and then times the area of the circle. Both of these formulas are located on your formula sheet. Let's look at how to apply them to some problems. Please look at your packet on the front page, Lesson Master 88A. For the top two questions, we are going to calculate both the circumference and the arc length given. So, we are actually going to use both exact form with pi in our answer, and then we're going to give the decimal approximation. So, to find the circumference in number 1, remember that circumference equals 2 pi r. That's hard to see. Let's retrace that. The circumference equals 2 pi r. So let's plug in what we've got. C equals 2 pi times the radius, which is 6. So our circumference equals 12 pi. That is my exact answer. That's the answer that I prefer. Now they also ask for a decimal approximation. So if we did 12 times pi, we would end up with 37.699. Okay, for part B, let's look at the length of the minor arc. So since the measure of the arc is 120, we're going to do 120 divided by 360, and then multiply that by the circumference, which was 12 pi. I end up with 4 pi. The decimal approximation is 12.566. All right, let's try another. We are asked to find, again, the circumference and the arc length in the circle shown below. All right, circumference equals 2 pi r. Circumference equals 2 pi times the radius, which is 30. So my circumference is 60 pi. The decimal approximation, 60 times pi, is 188.496. All right, to find the arc length, the measure of this arc right here, I'm going to do 45 divided by 360, and I'll multiply that by the circumference, 60 pi. This gives me a grand total of 7.5 pi. The decimal approximation, 23.562. Alright, let's try a few problems where we're asked to find some information that might not be given to us. So, for number 3, we're asked to find the circumference of a circle with diameter 5. Well, remember, we can also write circumference as pi times d. So 3 is easily enough, 5 pi. How about this? We're given the circumference, and now we need to find the radius. So remember, circumference equals pi times the diameter. I'm going to plug in 28 pi for the circumference. We can also write it as 2 pi r. I'm going to divide both sides by 2 pi. And I'm left with the radius of 14. Alright, 5 and 6, we have some space down below. We're going to calculate the length of a 45-degree arc of a circle with diameter 18. So we'll use our diameter to find the circumference. Our circumference here equals 18 pi. And now I need to multiply that by 45 divided by 360, because that's the measure of our arc. So 45 divided by 360 times 18 pi. That leaves us with 2.25 pi. Alright, last question about arc length. I've got a 90-degree arc of a circle is 20 centimeters long. Find the diameter. Alright, our arc length formula, if you remember, is the degree measure over 360 times pi times the diameter. Well, we know that is going to equal 20 centimeters. That's what was given to us in the problem. Now, let's take 90 over 360 times pi times the diameter equals 20. This reduces to 1/4, so 1/4 pi d equals 20. I multiply both sides by 4, and I get pi d equals 80. So my final answer for the diameter is 80 divided by pi. And I'm going to leave that in exact form. Now it's going to be your turn. Flip to the next page in your packet, and I'm going to have you complete problems 7 and 8 for homework. But for now, let's skip to talk about the area. Please turn your packets to 8-9A. Finding the area and the area of a sector are very similar to finding the circumference and the arc length. We're simply going to use our formulas. So if you'll remember, the area of a circle is pi times the radius squared. So if you look at the circle given at the right, in question number 1, the circle has radius 2, and the measure of the arc is 90 degrees. So our area equals pi times 2 squared, which equals 4 pi. The decimal approximation there is 12.566. Alright, now to find the area of the sector, that's this shaded region here, the degree measure is 90, and that belongs over 360. I'll then multiply it by the area, 4 pi. This is essentially 1/4 times 4 pi, and that's just equal to pi. And we all know that the decimal approximation for pi is about 3.14. Alright, for question number 2, we're going to refer to circle P over here. says if the area of the shaded sector is 10 pi, find the radius of the circle. So we know the area of the shaded sector, we need to work backwards to find the radius. Let's plug all the information that I know into the formula. I've got 150 over 360 multiplied by pi r squared, and that equals 10 pi. If I multiply by the reciprocal on both sides, 360 over 150, I'll get rid of my fraction, and I end up with pi r squared equals 24 pi. Now, I can divide both sides by pi, so r squared equals 24, so the radius will be the square root of 24. Now, we know about simplifying roots, so I can simplify from there. That would be the square root of 4 times the square root of 6, or 2 root 6. Alright, last problem. It says find the area of a circle whose circumference is 200 feet. Okay, so the first thing we need to do is find the radius. In order to do so, we'll use our circumference formula. 200 equals 2 pi r. Now, to solve for r, I can divide both sides by 2. So 100 equals pi r. And then divide both sides by pi. So the radius equals 100 over pi. Now, I will use that radius to find the area of the circle. Remember, area equals pi r squared, so pi times 100 over pi squared. Both the top and the bottom get squared, and my final answer is 10,000 divided by pi. There you have it, folks. That's how to find the circumference of a circle, the area of a circle, the arc length of a circle, and the area of a sector. Now it's your turn. I want you to finish the rest of 8-9A for homework, and we'll discuss it in class tomorrow. Hope you enjoyed your time learning about circles.
Mixed up world, you said you dropped them.